Something is wrong with Pluto. Not wrong in the way scientists politely disagree about classifications, wrong in the way that makes researchers go quiet in meetings, wrong in the way that rewrites what we thought we knew about the edge of our solar system, and maybe about life itself. In 2015, NASA's New Horizons spacecraft flew past Pluto after a 9.5-year journey across 3 billion miles of empty space. Everyone expected a dead, frozen rock, a lump of ice no bigger than the United States, drifting in darkness. What they found instead made scientists physically stop mid-sentence. Towering mountains of water ice, a vast nitrogen-filled heart beating on the surface, an atmosphere that shouldn't exist, geology that shouldn't be active, chemistry that, under the right conditions, could support life. And here's the part nobody is saying loudly enough. We still don't know what's powering it. Stay with me, because by the end of this video, you're going to see Pluto in a way that will never leave you. And you might start wondering, why did we spend so long looking at Mars when the most terrifying and fascinating world in our solar system was sitting quietly at the edge all along? Let's go back to 2006, because before we can understand what Pluto really is, we need to understand the strange, almost personal way humanity has treated this world. On August 24, 2006, the International Astronomical Union held a vote. 424 astronomers, out of roughly 10,000 in the world, gathered in Prague and decided, by a show of hands, that Pluto was no longer a planet. Just like that, a show of hands. The scientific justification was a new 3-part definition. A planet must orbit the Sun, have enough mass to pull itself into a roughly spherical shape, and, this is the part that doomed Pluto, it must have cleared the neighborhood around its orbit. Pluto shares its orbital zone with hundreds of other Kuiper Belt objects. Under this definition, it failed. But here's what most people don't know about that vote. It was deeply controversial. Many planetary scientists weren't even in the room. Some of the world's most respected astronomers voted against it, calling it geophysically absurd. Alan Stern, the man who built the New Horizons mission and spent 25 years of his life flying a spacecraft to Pluto, publicly called the decision embarrassing. Why does this matter? Because the demotion created a psychological effect that almost certainly delayed serious scientific investment in Pluto. For years, it sat in the cultural imagination as a footnote, a mistake, a childhood memory from elementary school posters. Meanwhile, Pluto was quietly doing something extraordinary. And this is the first thing you need to wrap your mind around. Pluto is not small in the ways that matter. It is the largest known object in the Kuiper Belt. It has 5 moons. Its largest moon, Charon, is so proportionately massive relative to Pluto that the two bodies orbit each other. They are, in a very real sense, a double planet system. Their common gravitational center floats in empty space between them. Think about that. 2 worlds locked in a gravitational dance billions of miles from the Sun in almost total darkness. And when New Horizons finally arrived, it found that both of them were stranger than anyone had imagined. July 14th, 2015, 7:49 a.m. Eastern Time. New Horizons made its closest approach to Pluto at 31,000 miles per hour. The spacecraft was the size of a baby grand piano. It had been traveling since January 2006, and for the 14 minutes of closest approach, it couldn't even phone home. It was too busy collecting data. Mission scientists at Johns Hopkins waited in silence. When the images finally came back, one feature dominated everything. Tumbar Regio, a vast, roughly heart-shaped region nearly the size of Texas and Oklahoma combined, glowing bright white against the darker surface. The internet immediately called it Pluto's heart. Scientists started calling it that too. But underneath the poetic nickname was something scientifically staggering. That heart is made of nitrogen ice, vast Cells of nitrogen ice, each hundreds of kilometers across, rise when they're warmer and denser with heat from below, then sink as they cool near the surface. But here's what stopped everyone cold. For nitrogen ice to convect on Pluto, there has to be a heat source. Pluto receives so little sunlight that its surface temperature averages around minus 230 degrees Celsius. That is close to absolute zero, the theoretical point at which all molecular motion stops. Pluto should be geologically dead, frozen solid, static. It isn't. The nitrogen plains in Tumbar region are geologically young. We're talking about a surface that was reshaped within the last few million years, basically yesterday in planetary terms. There are almost no impact craters on those plains, which means whatever is there has been renewed recently. The surface is being recycled. Hypothesis involves residual radiogeology, the slow decay of radioactive elements deep in Pluto's rocky core, releasing heat over billions of years. This is the same process that keeps Earth warm. But most models suggest that Pluto would cool too much for this to happen. A 2020 study published in Nature Geoscience suggested something more dramatic. Pluto may have had a liquid subsurface ocean for most of its history, and it might still have one today. Say that again. An ocean on Pluto right now, potentially. Not liquid water as we know it on the surface, a subsurface ocean, insulated with kilometers of ice, kept liquid not just by radiogenic heat, but possibly by something even stranger, a layer of gas hydrates acting as an insulator and trapping heat in. And if there is liquid water on Pluto, even deep below the surface, then everything we thought we knew about the conditions required for life just shifted.
Here's where the story gets physically disorienting. At the edge of Tumbar region, along the western border of the there are mountains, real towering mountains. Some of them rise 3 to 5 kilometers above the surrounding plains. That's roughly the Rocky Mountains. Water ice, not nitrogen ice, not methane ice, water ice. The same stuff freezing. Pluto's temperatures structurally stable. It doesn't flow or form at minus 230 Celsius. It holds its shape. But the existence of these mountains raises a new problem. What if? On Earth, mountains form from tectonic activity. Plates collide, crust forming, magma pushing up. Icy things like iron and robot, geological activity is driven by tidal heating, the gravitational squeeze from a massive nearby planet. But Pluto has no nearby massive planet, nothing to squeeze it. Its tidal relationship with Charon stabilized billions of years ago. So what pushed those mountains up? There are currently no fully satisfying answers. What scientists do have are clues that paint an increasingly wild picture. There are signs of ancient geological fault systems stretching across Pluto's surface, evidence that the crust expanded at some point in the past. When a subsurface ocean freezes, it expands. That expansion will push the crust outward, creating tension, fractures, and potentially mountains. This means the mountains may be scars, physical evidence of an ocean that froze, or, and this is the wilder interpretation, the ocean hasn't fully frozen yet. But the mountains are not even the strangest geological feature. On the far side of Pluto, New Horizons spotted massive structures that researchers informally described as bladed terrain. Enormous, blade-like ridges of methane ice, some as tall as skyscrapers, rising in parallel rows across the landscape. Nothing like this had ever been seen anywhere else in the solar system. At first, geologists assumed these were depositional features, methane snow piling up in ridges shaped by Pluto's extremely thin atmosphere. But then they looked more carefully, and the blades appeared to be erosional. They weren't built up from below, they were carved down from something larger.
There was once more methane ice here. Something removed it, and the process that removed it created these alien, knife-edged towers scattered across a world in near total darkness, billions of miles from the sun. Take a moment to actually picture standing there. Let's talk about Pluto's atmosphere, because this is where the story goes from surprising to genuinely unsettling. Pluto has an atmosphere. Not a trace, not a marginal technical detection, a real layered atmosphere with weather, haze, and complex organic chemistry happening right now. The atmosphere is primarily nitrogen, with traces of methane and carbon monoxide. It is extremely thin. Surface pressure is about 100,000 times lower than Earth's. But thin doesn't mean simple. The chemistry happening in that thin shell of gas is extraordinary. When ultraviolet radiation from the sun, even the weak sunlight at Pluto's distance, hits the methane in the atmosphere, it triggers photochemical reactions. These reactions produce fallings. This word doesn't get used enough in mainstream science coverage. Fallings are complex organic molecules, chains of carbon and nitrogen, the same class of molecules that are considered potential building blocks of life. They coat Pluto's surface in a reddish-brown layer. They drift through the atmosphere. They're found at Pluto. They're found in Titan, Saturn's moon. They've been detected in comets. They've been made in laboratory simulations of early Earth's atmosphere. Carl Sagan coined the term fallings in 1979 from nuclear for money. He understood their significance back then. These molecules, when exposed to water, can undergo further reactions that produce amino acids, basic components of proteins, and basic components of life. Life is complex organic chemistry, potentially biological chemistry. But here's what really doesn't make sense about the atmosphere. It's a secret. Pluto's gravity is weak, about 6% of Earth's. Its atmosphere is warmer, despite the general cold, that molecules at the top are moving fast enough to escape entirely. Scientists estimate that before new horizons, Pluto is losing its atmosphere at a significant rate. New horizons measured in scale. It was dramatic. Orders of magnitude. Something is slowing the escape. Something is holding the atmosphere in, or replenishing it faster than expected. Best is the interaction between the solar wind and Pluto's ionosphere, creating a kind of protective electromagnetic pocket. But the models don't fully fit. Pluto is holding on to its atmosphere in ways that current physics struggles to fully explain. And then there's the haze. New Horizons captured Pluto backlit by the sun during its flyby and revealed something that made atmospheric scientists do a double take. There are at least two distinct haze layers in Pluto's atmosphere, extending up to 200 kilometers above the surface. The haze is blue in scattered light. Blue on Pluto. The blue color comes from the scattering of light by tholin particles, tiny organic aerosols suspended high in the atmosphere. It's the same basic scattering process that makes Earth's sky blue, but seeing it on Pluto, this supposedly dead, distant, demoted world, was like opening a door you didn't expect to find there. Now look away from Pluto for a moment. Look at Charon. Charon is roughly half the size of Pluto. It orbits so close that both bodies are tidally locked. They always show the same face to each other. From Pluto's surface, Charon hangs permanently in the same spot in the sky, never rising, never setting, just fixed there, like a gray moon someone nailed to the horizon. For a long time, scientists expected Charon to be geologically boring, old, cratered, dead, a passive partner. Then New Horizons flew past and revealed Charon's North Pole. It's red. Not slightly reddish, a striking rust-colored cap covering Charon's entire North Polar region. Informally named Mordor Macula by the team, and yes, that name was approved, This feature had no easy explanation until someone made a connection. Pluto leaks. Its atmosphere, thin as it is, constantly loses molecules to space, and a significant portion of those escaping gases, methane, nitrogen, don't escape entirely. They get captured by Charon's gravity. They freeze onto Charon's poles during the long winter nights, which on the tidally locked Charon can last decades. Then, when the polar winter ends and sunlight returns, the nitrogen and methane sublimate. They vaporize back off the surface. But the heavier molecules, the tholins, the complex organics created by photochemistry, those don't sublimate as easily. They stay. They build up, season after season, century after century, over billions of years. The red cap on Charon is the accumulated organic chemistry of Pluto, transported across the 19,000 kilometers between the two worlds, deposited like evidence of everything Pluto has been cooking up in its atmosphere for 4 billion years. It is, in a sense, a record, a chemical diary written in the sky between the two worlds, and it raises a question that's quietly becoming one of the most interesting in planetary science. If Pluto is producing complex organics at this scale continuously over geological time, and if there is a subsurface ocean providing liquid water, what exactly has had the time and conditions to form down there? Nobody is saying life, not officially, not yet, but the question has moved from impossible to genuinely open. Here's a reframe that changes everything. We've been thinking about Pluto wrong because we've been thinking about it in isolation, as a lonely oddity, a failed planet made of age. But Pluto is not alone. The Kuiper extends from Neptune's orbit at 30 AU out to approximately 50 AU from the Sun. 1 AU is the distance from Earth to the Sun, 150 million kilometers. So the Kuiper stretches across a region more than 1 billion kilometers deep, and it is populated by hundreds of thousands of objects. Pluto is the king of the Kuiper belt, the largest known Kuiper belt object. There are others. Eris is nearly the same size as Pluto. Hopkins, Haumea, which rotates so fast that it's shaped like a flattened planet, spinning a full rotation in just under 4 hours. Sentinel, which has one of the most elongated orbits in the solar system, swinging out to possibly 900 AU from the Sun. And beyond even these, there is theoretical evidence for something much larger. You may have heard of Planet 9. The hypothesis, developed primarily by Caltech astronomers Constantine Bettigan and Mike Brown, proposes that a planet approximately 5 to 10 times Earth's mass exists in the far outer solar system at distances between 400 and 800 AU from the Sun. The evidence for Planet 9 is indirect but compelling. A cluster of Kuiper belt objects have orbital paths that are statistically aligned in ways that seem almost impossible by chance. The probability of this alignment occurring randomly is estimated at less than 1 in 500. Something appears to be shepherding their orbits into pattern. If Planet 9 exists, then Pluto and the Kuiper belt are not just the edge of the solar system, they are the visible tip of a vast, semi-organized outer structure, a gravitationally sculpted region shaped by a world we haven't even confirmed exists yet. And here's the implication that nobody discusses. If Planet 9 is real, it formed somewhere in the inner solar system and is ejected outward, possibly by a gravitational interaction with Jupiter or Saturn in the early chaotic history of planetary formation. It has been out there, in the dark, for potentially 4 billion years. What is a planet like after 4 billion years in the outer dark? We have no idea. We've never seen anything like it. We barely have the telescopes to find it. One more thing that doesn't get enough attention. Everything New Horizons found on Pluto, the active geology, the young surfaces, the organic chemistry, the potential subsurface ocean, All of this suggests that Pluto is not a relic. It is not a frozen snapshot of the early solar system, sitting untouched since formation. It is dynamic. It is changing. It is, in some sense, alive in the geological meaning of the word. And this has profound implications for how we understand the outer solar system as a whole. For a long time, planetary scientists assumed that bodies at Pluto's distance were essentially primordial, preserved cold storage units from the birth of the solar system 4.5 billion years ago. Study them and read the original recipe. But if Pluto has been geologically active all this time, if it has been processing its own material, maintaining a dynamic atmosphere, potentially cycling an ocean, then we've been wrong about what the outer solar system is. It isn't a museum, it's an ongoing experiment. Here's the part that should keep you up at night in the best possible way. We have visited Pluto once. One flyby. New Horizons raced past at 31,000 miles per hour and couldn't slow down. It had no orbital insertion. The entire close encounter lasted a matter of hours. We saw one side of Pluto in full daylight. Half of the surface was in complete darkness the entire time. We have never seen the other side of Pluto up close. What's over there? We have some data, long-range observations, some partial imaging, but nothing like the detail of the other side. The far side of Pluto is one of the largest unmapped terrains in the solar system, and given everything we found on the side we did see, the imagination limits. There are currently no funded missions to return to Pluto, no spacecraft in development, no orbital probe in the planning stage that will secure mass of Pluto. The next chance to see Pluto up close, assuming we start today, is probably 20 years away. 20 years. Meanwhile, Pluto sits out there, its heart slowly convecting, its mountains standing in total darkness, its organic hills drifting in an impossible atmosphere, its hidden ocean exists, doing whatever it has been doing for 4 billion years. Now here's where I want to go. We spent decades treating Pluto as a footnote, devoted also too small, too far, too cold, too unimportant. We looked at it through telescopes for 75 years and saw only a smudge. We argued about its classification. We made elementary school posters. For the entire time, it was doing this. The real tale isn't what it contained. The real tale is what our assumptions cost us. If a world that receives 100 of the sunlight Earth does and has mountains, active geology, complex organic atmosphere, and a potential subsurface ocean, then what are we missing on the hundreds of other Kuiper Belt objects we've never examined closely? What about the moons of Uranus, which we last flew past in 1986 with Voyager 2 for a few hours? What about the small, icy bodies scattered across the outer solar system that we've literally never looked at? The history of planetary science is a history of assumptions being destroyed by data. We assumed Venus was tropical. We assumed Mars was geologically dead. We assumed Europa was just another icy moon. We assumed Enceladus was boring until Cassini found it was spraying liquid water into space. Every single time we go somewhere and actually look, we are shocked. Pluto is the most recent entry in that long, humbling list. And what it tells us is this: the threshold for complexity, for chemistry, for geological life is far lower than we thought. You don't need to be close to a star, you don't need to be large, you don't need to be obvious, you just need time. And the solar system has had 4.5 billion years. Think about how many worlds are out there. Think about how few we visited. Think about what each of those visits found. And then ask yourself, what is sitting quietly in the dark right now, doing something extraordinary, waiting for someone to finally show up and look? Pluto was never what we thought it was. It wasn't a failed planet. It wasn't a frozen relic. It wasn't a footnote. It is a world with mountains and oceans and organic chemistry and a beating heart of nitrogen ice, and we know almost nothing about half of its surface. It is the loudest argument against the comfortable idea that we understand our own solar system. The universe is not waiting for our permission to be complex. If this video changed how you see our solar system, even slightly, I'd love to know what hit you hardest in the comments. And if you want to go deeper on the subsurface ocean hypothesis, the Planet 9 evidence, or the full story of the New Horizons mission, those videos are coming. Stay curious and look at the edges. That's usually where the real story is.